Hello class. Sorry it's taking me so long to get this video up. I was grading SATs last night for 5 hours, so I ran out of time. So we're going to do today, we only have 2 examples. These are value problems. These are problems that are just like coin problems, like number of nickels, number of dimes. Only this time we're going to talk about different things besides just coins, but we're going to do them the exact same way. So if you got coin problems, then this isn't going to be difficult. If you didn't get coin problems, then maybe this is looking at it a different way might be helpful. So let's look at an example here. It says, airline fares for flights from Tifton to Adel are $30 for first class and $25 for tourist class. If a flight had 52 passengers who paid a total of $1,360, how many first class passengers were on the trip? Well, that one sounds really complicated with nothing else. But again, we're going to have value, a value equation, and we're going to have an equation that just stands for the number of items or tickets or people. So we're going to do our 2 equations. Let's see, we have, for this one, we have airline fares, we have the first class, and we have a tourist class. So they're going to be our 2 variables. So we're going to have the number of first class plus the number of tourists. Now this is our one that just has to do with how many tickets were sold. This has nothing to do with the fact that there's $30 for first class and $25 for tourist class. Remember, this is just the number of people on the flight or the number of tickets that are sold. So if a flight had 52 passengers who paid a total of $1,360, how many first class? So we know that the number of first class passengers plus the number of tourist class passengers, that's just the number, like how many nickels and dimes you have. We're just talking about how many people we had, was 52. The second equation, doesn't matter which one you do first, but the second equation is your value. You can see we're dealing with dollars. So your second equation has to do with dollars. Every single term has to do with dollars. So we have $30 for first class. So it's going to be 30 times the number of first class. And then we have our tourists, which were $25 for number of tourists. It's always good to line these up, have the same variables line up. Equals our value, which is $1,360. So this is just the number of passenger, has nothing to do with anything about money at all. It's just number. And this one has to do with value, so every one of these has to do with money. Once we do this, typically the best way to do these is by elimination. So I'm just going to multiply one of these equations by something. I'll just multiply the first one by negative 30. That way, these 2 will add out. So let's just do that over here. So we're going to have minus 30, number of first class, plus minus 30, number of tourist class, equals, and then we're going to take minus 30 times 52, which would be minus 1,560. So you have to multiply negative 30 times all of these. And now we're going to add it to the second equation. Remember, this is our elimination method. Plus, we don't change anything on this one. 25, number of tourists, equals 1,360. So when we add this together, we're going to get, if we add these together, we get minus 5, number of tourists, equals minus 200. If you come out with a negative answer and you're trying to figure out how many people, you probably did something wrong. But since we have negative on both sides, and we divide a negative by a negative, we're going to get a positive. So the number of tourists on the plane would be 40. But they don't want to know that. They want us to find out how many first class passengers. So we would take this amount, this is a tourist, here's our 40, put that up there, and for that, so we get the number of first class plus 40 equals 52. And so we get number of first class people would equal 12. And these are just like the coin problem, so if you understood the coin problems, these shouldn't be a problem. Let's try one more. Waukesha's dress shop, I'm not going to say that again, sold less expensive dresses for $20 each and more expensive ones for $45 each. The shop took in $1,375 and sold 20 more of the less expensive dresses than the more expensive dresses. How many of each kind did they sell? Well, this is a little bit more confusing because they're saying in this sentence they sold 20 more of the less expensive than the more expensive dresses. So on this one, let's set up our two equations. We know we have our value equation. So we're going to get, for a value equation, that would be all the ones here with money, would be all in the same equation. So we need to have our variables. So 20 times the number of less expensive dresses, because it's $20 for, for the more, for the less expensive, plus 45 for the expensive dresses is going to give us 1,375. All the things with value in it are in one equation. 20 times the number of less expensive plus 45 times the more expensive dresses equals 1,375. So that's our value. I always call that the value equation. Now we have one that just has to do with how many dresses were sold. Well, we know the number of less expensive dresses is 20 more than the more expensive. So in order for this equation to balance out, if we just put them equal, there's more less expensive ones. So if we just put them equal, this side would be heavier, right? The less expensive would be more. So we need to balance our equation. In order to do that, we need to add 20 on to the more expensive side so that our equation is balanced. There's more less expensive, so we have to add 20 onto the more expensive so our equation is balanced. Now instead of this being an elimination, since it's already solved for one of these, we may as well just substitute. So we're going to take, instead of the number of less expensive, this variable right here, we're going to substitute what NL equals. We're going to put that back up there. So we're going to have 20 times the number of more expensive plus 20 plus 45 number of expensive dresses equals 1375. Do you see the difference why we're using substitution here? Because we're not having two equations that line up where we can just multiply. It's already solved for one of the variables, so it's easy to substitute. That's why we learned both substitution and elimination, because sometimes one method is easier than the other, depending on how you set up the equation. So then we're just going to distribute. So we get 20 number. I mean, you could always do this by elimination. You could subtract. Oops, I have different variables here, don't I? That's a little bit of a problem. Number of less expensive. This should be E for expensive. This should be E. That's really bad. I have different variables. So 20 number of expensives plus 400 equals 45 number of expensive dresses equals 1375. And we add that up, we get 65 number of expensive dresses. Can't even say that. Subtract 400 from both sides. And we get 975. Divide both sides by 65, so the number of expensive dresses equals 15. And the number of, what are they asking for? How many of each kind? So the number of expensive dresses would be 15. So we go up here, and the number of less expensive would be 15 plus 20, which would be 35. So hopefully, despite my putting the variables naming them two different things when you got this. So just remember, you have one with your value. All the money, guys, should be in one equation. And then one's just talking about the number of items, should be in the next equation. So less expensive equals expensive plus 20. So hopefully you got that, and I'll have the other videos the day before we need to do them so we don't run into this again. So that's it for lesson 89.